All right. So after this lecture, I'm going to put up the quiz. I'm going to put it both on my website and I'll also send it out through Remind. So be on the lookout for that quiz. Also, make sure you get in your homework today by 11:59, 59, 59. So we're going to start by quickly going over Pascal's Triangle. Again, because I only have 30 minutes, it's going to just like pass over a lot of things. Pascal's Triangle has so many cool things associated with it. So if you don't already know about Pascal's Triangle, this is a part of Pascal's Triangle. It continues on and on and on and on. And there's a certain pattern to it. So the pattern is that these new numbers at the bottom are the sums of the diagonals and above it. So we can continue this pattern. So we would have 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, 5, and 1. So important things for the Pascal triangle, the outsides are always going to be 1s. Also, what's really cool about Pascal's triangle, well, I'm getting ahead of myself. So this first row is actually considered the 0th row. And this first item on any particular row is actually called the 0th item. So then we have the 0th, 1st, 2nd, 3rd, 4th, 5th. And this was on the 0, 1, 2, 3, 4, 5th row. So one way to kind of determine what row you're on, it's always going to be this first, or the first item's number. So here's row 1, row 2, row 3, row 4, row 5, so forth and so on, and you can continue this pattern on and on and on and on. Again, there are so many cool things about this pattern. Please, please, please go and look it up if you have time or if you're even interested. One also really interesting thing about this is that each of these rows and each of these items actually compares to if I were to do a choosing. So in choose R, so a combination here. So let's say that I wanted to know, I have 5 and I want to choose, let's say 3 of the items. Well, if I go to the 5th row and go to the 3rd item, 0, 1, 2, 3, 5 choose 3 is actually 10. So forth and so on. And that's true for every single one. So we're going to be using this fact that any item on the Pascal's triangle can be determined using this notation. And again, this is the more appropriate notation we are going to be using. This is the nth, and this is your R or K, depending on who you're talking with. So this is 5 choose 3, and if we went to the 5th row and went to the 3rd item, remember starting with 0 being, so 0, 1, 2, 3, so 5 choose 3 is actually equal to 10. So we're going to be using this fact a lot today. So if you have time, I would almost suggest that you pause at this point in the video, go on to the lecture notes, and actually work through the slide that says powers of binomials, and try to see if you can start to see the pattern that actually starts to emerge when you start doing these powers to a binomial. So what I mean by that is that start with a plus b to the 0, then a plus b to the 1st, so forth and so on. And as you keep raising these powers, start to see what kind of, you may notice patterns to them, and there is going to be patterns. So again, if you want to try to figure this out on your own, pause now. Otherwise, I'm just going to have to go through it, because in class I would have liked you to try to see the pattern yourself. But just like with de Moivre's theorem for our complex numbers and how we were raising powers to those complex numbers, and there's like a pattern involved with those. There's a pattern involved with actual real numbers as well, binomials being raised to some kind of power. So let's see. I'm just going to write one out. Let me do the fifth. So a plus b to the fifth. So I'm going to write out what this expansion would be without doing any kind of math. So this is going to be 1 a to the fifth plus 5 a to the fourth b plus 10 a to the third b squared plus 10 a squared b to the third plus 5ab to the fourth plus 1b to the fifth. So instead of actually having to multiply this binomial over and over and over again, so a plus b times a plus b times a plus b times a plus b times a plus b, work out all that math, it simply just comes down to this right here. And the reason why I can do this so quickly is because there is a pattern to this. So notice that I'm raising this to the fifth power. If you also remember what the fifth row of for your Pascal triangle's fifth row was 1, 5, 10, 10, 5, 1. Notice all of my coefficients, 1, 5, 10, 10, 5, 1. So that is part of the pattern. I went to the fifth row and I put out all of those numbers. So also, if you notice that here I'm starting from a to the fifth power, and every single term my exponent is actually decreasing by 1 until there's nothing left. And the same with b, but b is increasing over time. So to kind of help you, this is actually going to be b to the 0th power, and anything raised to the 0th power is 1, and that's why it doesn't exist. So we have 0, 1, 2, 3, 4, 5, and for our a's, we were decreasing, so a to the fifth, fourth, third, squared to the first, and technically there is an a to the 0th here, but that is 1, so that's why it's not written. So those are the three patterns for a binomial distribution. So another way to write this is with the with a different notation. This is your binomial theorem. So it's nr times a to the n, b to the this is n minus r, and this is r. Alright, so n choose r, a, n minus r, b to the r. And basically what this is doing is, first we're finding out what this coefficient is by determining what row we're on and what term we're on. So this is our 0th, 1st, 2nd, 3rd, 4th, and 5th. Notice that I have one more term than I started with for my exponent, because we have this 0th term right here. And every time I'm simply doing 5 minus 0 is 5, and my r value was 0. Same, 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 same. And another nice thing about this pattern is that these numbers up here should add up to this exponent that you were raising it with in the first place. So that's another way to kind of check yourself as you're doing this pattern. So this just continues on and on and on until you've reached where r equals n. So then it would stop, because here my b value was now r, which was that 5, so forth and so on. So I'm going to do a couple of these examples because there's a couple different types of questions that they could ask with this, and I just want you to kind of understand. I know I'm going really quickly, but again, I now only have 20 minutes, and I'd rather spend the time actually doing some examples to show you how this actually works. But again, you're using that Pascal's Triangles row, depending on whatever exponent you're raising it to. And then this first term, its exponent starts at that exponent and it decreases. The second term in this binomial starts at 0 and it increases until it gets to that exponent. And again, you can check yourself by making sure that every single time when you add your exponents together, they should equal whatever exponent you're raising it to. Alright, so let's look at some examples. Alright. So, again, let's say that I don't remember all of my rows of my Pascal's Triangle. I don't need to remember all of my rows of Pascal's Triangle. So, what I'm going to do is I'm going to start with an easy example and then I'm going to move on and do some harder ones. So, this time, I'm going to do a plus b to the 8th power. And this time I'm saying I don't know what the 8th row is off the top of my head. Sure, I could go and look at a list and I can see what all those coefficients are, but instead I'm going to use that nChooseR method to find out what that coefficient should be with using my calculator instead of looking at whatever row I'm looking for. So I'm going to the 8th power. So what I'm going to do is I'm going to put out blanks. And my blanks are always going to be one more than whatever exponent I'm asked to expand. So we have here, this is going to be my 0th, 1st, 2nd, 3rd, 4th, and I've run out of room, 5th, 6th, 7th, and 8th. So I have 9 different terms here. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8. So as long as you start at 0 and you end up at your 8, you know you're doing it right. So now I'm going to start filling in my blanks. So the first thing I'm going to do is I'm going to go ahead and just write out the choose method for every single one of this. So this is going to be 8 choose 0 because I'm at the 0th item. This next one would be 8 choose 1, then 8 choose 2, 8 choose 3, 8 choose 4, 5, 6, 7, and 8. So I've done the first part of my pattern, which is that every single coefficient is going to be whatever row I'm talking about on the Pascal's Triangle, and then whichever item. So we're starting at the 0th item, always, 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 always. So as you can see, when I went through this, I came up to get 8 choose 8. So I've hit every single one of these numbers. So the next thing is, I'm going to take this first term, whatever the first term is. Doesn't matter. It could be a, it could be 3xy, it could be who cares. But what I'm going to do is I'm going to start with that a, or whatever that first term is. I'm going to raise it to the highest power. Please, 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 if you want to do this properly, put your terms in parentheses before you raise the powers. So this is going to be a to the 8th. I know it doesn't matter for a single a single variable or with a coefficient of 1 or anything like that, but when you get into harder problems or whatnot, when there's a 2a or 2xy or something like that, put it in parentheses so you know that squared or whatever goes to every single one of those items in that term. Alright, so the next one I'm going to decrease. So we went from 8 to 7 to 6 to 5 to 4 to 3 to 2 to 1 to 0. So we did the first pattern, which was our coefficients using our choose. The second pattern is that your first term is going to decrease as you go through. The next piece is you're going to take the second term of whatever this binomial is. You're going to start it at 0, and you're just going to increase. So this is b to the 1, b to the 2, b to the third, fourth, fifth, sixth, seventh, and eighth. So I know it looks messy because there's a lot of parentheses right now, but we need those parentheses to be able to figure out what, if this was like a 2b to the 5th would be, so I would have to do 2 to the 5th power and then multiply it by whatever comes out to that one, yada yada yada. So now what I have to do is I now need to just put this into my calculator for these choose methods to figure out what's going to be what. So 8 choose 0. I'm saying, hey, I have 8 items, but I want to choose none of them. Remember, if you're choosing none of them, you should get out 1, because there's only one way to choose nothing, and that is to choose nothing. So 8 choose 0 is just going to be 1. A to the 8th is a to the 8th. B to the 0 is 1, so I don't need to write that. 8 choose 1 is 8. A to the 7th, B to the 1st power. So 8 choose 2 gives me 28. So this is 28. A to the 6th, B to the 2nd power. 8 choose 3 is 56. So this is plus 56. A to the 5th, B cubed. Next we're on to the 8 choose 4, which is 70. A to the 4th, B to the 4th. Then 8 choose 5, which is 56. A to the 3rd, B to the 5th. Over here is now 28. A to the 2nd, B to the 6th. Over here, so then plus the next term, 8 choose 7 gives us out 8. So this is 8. A, B to the 7th. 8 choose 8. We have all the items, and we're choosing all the items, which means there's only one way to choose all the items. So plus 1. A to the 0th is 1. B to the 8th. So that is the total expansion of a plus b to the 8th without having to do all of the different multiplication and adding like terms. You can do this a lot quicker. Alright, so I'll give you a second to kind of screenshot this or whatever you need to do. Then we're going to move on to some more examples. Alright. So a couple other questions that they could ask is, what would be the coefficient of a particular term? It may ask you for just a particular term, or it may ask you for the whole expansion. So as you can see, the whole expansion takes a lot. If they were asking for a particular term, they may say, for example, hey, what's the 5th term? So when they're asking about what's the 5th term, there's basically, they don't mean, hey, start counting at 0. The fifth term, you still count at 1. So this is the first term. This is just the 0th item. This is the second term, first item, so forth and so on. So really the fifth term is going to be something over here. So this right here is the fifth term. So instead of having to do all of this work, I just have to find the work for just this one right here. And then do the math and figure out whatever that fifth term is, which is 70 a to the fourth b to the fourth power. So let's do a couple of those examples. I got like 10 more minutes. Alright, so we're doing an example of the coefficients. So it says find a coefficient of x to the 10th. So I'm trying to find what is the coefficient to the x to the 10th term in the expansion of x plus 2 to the 15th power. So I'm trying to find out x to the 10th. So the nice thing about the pattern is I can start to fill out some blanks until I get to the spot I need to just stop at and just look at what that pattern is there. So we're trying to find the 10th term. So this one right here is going to be to the 15th power because we start at the 15th and I'm looking at my first term. So then the next one is going to be to the 14th, to the 13th, 12th, 11th, and 10th. So there's a lot of different ways that you can go about this. I'm just trying to show you a visual way of figuring out where it's going to be located. If you figure out a quicker way, because there's tons of quicker ways of doing it, then please do that. But this is for everybody. So here we started with the 15th because I was at the 15th power for this x and I started decreasing my value. So this is what I'm looking at right here. So I care about whatever this coefficient is going to be. So here I know that, so one of the nice things is I now know that I'm here, that my exponents need to add up to give me 15. So that means that this right here is going to get multiplied by the second term, or the second term of this binomial, 2. I'm going to raise that to 10 plus what is 15, and that's to the 5th power. What's also really nice after you've done this is that your choose, so we already know it's going to be 15 choose something, the choose something is going to be that second term's exponent. So this is going to be 15 choose 5, because this was your 4, 3, 2, 1, and 0. So when you figure out where you're located using one of your terms, then you're good to go, because then your two exponents need to add up to that 15, and then your choose is going to be whatever that second term's exponent was. So now we can just go and figure this out. So 15 choose 5 is 3003. So this is going to get multiplied times 2 to the 5th, which is 32, times that x to the 10th. So 3003 times 32 gives me 96,096 x to the 10th. So my coefficient that they want is that 96,096. So again, to repeat what we just did, they asked us for the x to the 10th coefficient. So I went and I said I'm starting with my first term, 15, and I'm going to decrease it because I'm trying to find the x, and x was the first term. So I'm decreasing the value until I hit x to the 10th. So then I know that 10 plus 5 equals that 15, so I know that the second term's exponent needs to be 5. And that 5 is also going to be that 15 choose 5. So these two values right here are always going to be the same. So the second term's exponent is going to be the same as what you're choosing from your whatever the original exponent was that you're raising it to. All right, let's do another problem. So I'm just going to make up one. So I want to know what the fifth term of 2x plus 3y raised to the 17th power is. Well, that's going to be ridiculous, but whatever. So I'm trying to find out the fifth term. So what I'm going to do is I'm going to write out 5 blanks. So 1, here's my first term. Second term, third, fourth, and fifth. So this is the value that I am looking for. So I don't need to fill out all of the information. I don't need to continue on and yada yada yada. So what I'm going to do is I'm going to start decreasing my exponent until I get to this one right here. So I'm going to take this first term and I'm going to decrease its exponent until I get to that fifth term. So this would be 2x to the 17th, 2x 16, 2x 15, 14. So this last one is 2x to the 13th power. So please put your binomial terms in parentheses, because not only is that x being raised to the 13th power, but that 2 is also being raised to the 13th power. So we know that this is going to get multiplied to the second term, which is 3y, and the power it's going to be raised to is 4, because 13 plus 4 is 17. So the last piece out of the 17, I'm going to be choosing 4 of them. So now that we have this piece of information, I am just going to go and calculate each pieces of these by raising them to their respective power. So I got to figure out what 17 choose 4 is. Then, since this is going to be 2 to the 13th, x to the 13th, because I'm going to basically distribute that exponent to each of those. So then over here, this is going to be times 3 to the 4th, y to the 4th. So let's figure out each piece of these. So 17 choose 4 gives me 2,380. 2 to the 13th power gives me 8,192. 3 to the 4th, 81, times x to the 13th, y to the 4th. So I just need to multiply those numbers together. So 2,380 times 8,192 times 81 gives me huge number. And that's it. This right here is the fifth term of this expansion right here. Alright, so I hit my 30-minute mark. So if you have any, so the homework, there's 2 sheets. You only have to do the first sheet. I'm going to put a note on the homework page that you only have to do the first one. The second one is if you want practice with harder ones, like this where there's a coefficient in front of those variables, accelerated, I highly recommend that you do some of those problems, because I mean honestly it's not bad, but you have to start thinking about where things are, and hopefully some of you will start figuring out ways of not having to write all of these down, because there are really nice ways of doing that, but I'll give that to you to find on your own pattern. At this point I'm going to look at any questions. Otherwise, look out for that quiz that I'm going to be posting shortly. There's 2 homeworks due today, the permutations and the combinations homework. I can't remember the dates. I think one was the 13th and the other was like the 2nd or 3rd of April, one of those 2. So please email those to me if you can make them into a PDF. That would make my life a lot easier, and it will give you a great opportunity to learn how to make documents into PDFs using your phone. So I'm going to look at any comments or questions. Yeah. What you got, Zenon? Or do you want to just message me and I can answer that way? That may be quicker. Alright, so that's it for the day. Again, look out for that quiz. Good luck. It should only take, like, if you really know what you're doing, potentially less than like 8 minutes. If you don't know what you're doing, I'd still say probably within like 30-40 minute range. Shouldn't take too long.